Okay, now the third type of question that can be asked in this exercise is something like this. You've got to express the square root of 5 plus 12i in the form a plus bi. Now the numbers a and b both have to be real, so you can't get any complex answers there, complex number answers. Right, so our first step is we're going to say, just a second. We're going to say that the square root of 5 plus 12i is equal to a plus bi. Now we're going to square both sides. If I square this side, I get 5 plus 12i, and then I need to square the other side. And again, I'm going to use my shortcut to square this. I'm going to say the first to be squared is a squared, the second to be squared plus the second to be squared is b squared, I squared. And then twice their product would be 2abi. Now don't forget that I squared is minus 1, so you end up with a squared plus 2abi. That's a minus 1 times b squared is minus b squared. Now next thing is to group the reals together on the right hand side and the imaginary parts. So the reals are those things that don't have an I attached, if you like. So you get a squared is one of them, minus b squared. So that's the real part. And then the imaginary part is 2ab, and then times I. Our next step is to compare the real on the left, the real on the right, and we end up with 5 equals a squared minus b squared. And that's our first equation we're going to use. And the second thing is, if we compare our imaginary parts, now you discard the i's, okay, you're only taking the coefficients of the i's, so you get 12 equaling 2ab. And then I can, actually I just mark the next one, I can change that further. Firstly, I can cancel the 2, I can say 6 is equal to ab, and then I can say that a is equal to 6 over b. That's my second equation. Now I'm going to slot that back into, this is equation number 1. Okay, so 5 is equal to, now I know that a is 6 over b, so I'm going to put that in for a here, 6 over b minus b squared. So what I'm doing is I'm subbing that a value back into this equation number 1. So subbing in. Okay. All right, my next step is to get rid of the b here. Sorry, that's got to be a squared, excuse me. Okay, you see a squared up here and a squared here. Okay, so let's first square that up. That's a 36 over b squared minus b squared equals 5. Now I want to get rid of that b squared on the denominator. So what I'm going to do is I'm going to multiply everything by b squared. This becomes 5b squared. If I multiply this by b squared, I just get 36. And if I multiply b squared by b squared, I get b to the power of 4. So what we did there was multiply by b squared. Now I'm going to rearrange that to make it look like a quadratic. Okay, so the b to the 4 goes across, plus 5b squared minus 36 equaling 0. Now we're not used to having something to the power of 4, but I just want you to compare it to your typical quadratic. Let's say we had x squared plus 5x minus 36 equal 0. How would we factorize that? Well, first the x's would go in here. X times x gives me x squared. Now the factors of 36 that combine to give me a 5 are 4 and 9. And then my signs are different because of the minus in this position, and they have to get a plus 5, so it's a plus 9 minus 4, so you get plus 9x minus 4x is plus 5x. Now compare this to this. What we're going to do first is we're going to factorize the b to the 4, and the only possibilities are b squared. Well, the possibilities we're going to use are b squared and b squared. 36, similar to here, you're going to put a 9 and a 4 and a plus and a minus. So you can see the similarity between this and this. And again, equaling 0. Now, let's take case 1. This thing could be equal to 0. B squared is equal to 4, in which case B would be equal to plus or minus 2. Case 2 would be that this thing here could be equal to 0, so B squared is equal to, or let's say plus 9. Equal to 0. B squared is equal to minus 9, and then B would be equal to plus or minus the square root of minus 9, which is plus or minus 3i. Okay. Again, where did that come from? Just let me briefly explain. You have, plus or minus the square root of minus 1 times the square root of 9, and that is equal to plus or minus square root of 9 is 3, and then square root of minus 1 is I. Now, if you remember at the beginning of the sum, both A and B have to be real, but these are imaginary solutions, so we discard those, and we're going to use only case 1 solutions. Alright, so if B is equal to plus 2, A is equal to, now if you remember A back here, A was equal to 6 over B, that's up above, and that's equal to 6 over 2, which is a 3. Now, if B were equal to minus 2, you would get A equals 6 over minus 2, which is equal to minus 3. So our answers are A plus BI could be equal to, firstly, this A here is a 3 plus, and the corresponding B is a 2i, or could also, for this case here, A is minus 3 and B is minus 2 times I, and that is your final answer. So there's 2 possibilities. Okay, so go ahead and have a look at the exercise and do every odd sum, see how you get on with that. Thank you.